All right. Abeka, Algebra 1, Chapter 2.4, Clearing Fractions. Probably one of the most common things that I ever hear from students or people that I'm helping is, I hate fractions. Pretty common among people that don't like math is to hate fractions. So the nice part about this section is what if we could do away with fractions? What if we could not have to deal with them for a minute and just work with whole numbers? All right, so let's look at how do we clear fractions. So let's take a problem like, I'm looking at example 2.4a. We have 5x over 8 plus 1/4 equals 4. All right. So right out of the gate, we hate it because it has letters in it, it has fractions in it, all the things that we talked about we don't like. This puts in there together. So let's see if we can get rid of those fractions. Step one is I need to identify my LCD, or the least common denominator. So I've got three different things here. I've got 5x over 8, I've got 1 over 4, and I've got 4. So between those three things, what is the least common denominator? I'm always going to start, we understand this is technically over 1. To find my LCD, I'm always going to start with the biggest denominator. So I'm going to start with 8. It's bigger than others. So I know 8 goes into 8 one time. Does 4 go into 8? Yeah, it goes in there twice. And does 1 go into 8? So there we go. Our LCD, I've identified my LCD as 8. All right? Now with that, step 2 is multiply both sides by the LCD. All right, so if I multiply this side by 8, and I multiply this side by 8. On this one, when I multiply it, we've got to distribute it. We know how to distribute it. I multiply it times this term first. The 8, I'll put it over 1 so it's a little easier to see what's going to happen here. Anytime when I'm multiplying fractions and the top and the bottom have anything in common, I can get rid of it or reduce it. So I'm going to get 8 over 8, that cancels out, leaving me with 5x over 1. Another way, if you don't like that, you could have said the top times the top, the bottom times the bottom, and then reduce. So if I do 8 times 5, I get 40. 40 divided by 8 is 5. All right, so either way is fine. Plus, we'll do this one the second way I said. 8 times 1 is 8. 1 times 4 is 4. So 8 divided by 4 is 2. Equals 8 times 4 is 32. All right. So I've cleared the fractions. I went from 5x over 8 plus 1/4 equals 4, something that a lot of us would have wanted to just throw our pencil away before we even started. And I made it into something that's pretty straightforward. Now I just need to isolate the variable, get the letter by itself. I do that by using the addition property of equality right now, so I know that I can add or subtract anything from this side as long as I do it to that side also. So I'm going to do the opposite of what's being done. I'll move that constant over here, subtract 2 from both sides. I get 5x equals 30. Now I'm going to use the multiplication property of equality that tells me I can multiply or divide both sides of the equation by anything I want, and it still remains equal. I want to get rid of that 5. Right now it's being multiplied. The opposite of multiplication is division. So I get x equals 30 divided by 5 is 6. All right, we can always plug that back in and check it. But once I've isolated my variable, I get x equals 6. That's a lot easier to work with than all the fractions that we would have been doing to start with. All right, so step 3. Once I've cleared the fractions by multiplying by the LCD, is solve by isolating the variable. All right, so we have 3 steps. Granted, solve by isolating variable could have multiple steps in and of itself, but we've learned how to isolate a variable Today we're focusing on how to clear these fractions out. All right, let's look at another example. Example B that they gave us is, we've got y over 6 plus y over 2 equals 10 thirds. All right, so again, step one, identify the LCD. I'm going to do that by starting with the biggest denominator, which is 6. 6 goes into 6 one time, 2 goes into 6 3 times, 3 goes into 6 2 times. Because all three of these go into 6, my LCD is 6. So I'm going to multiply both sides by 6. I'm writing this 6 over 1, so we see it the same. We have to we know there's an understood 1 here and an understood 1 there. So 6 times 1 is 6, divided by 6 is 1. So I'm left with, do that one more time. 6 times 1 is 6, so I would have 6y on top, divided by 6 is 1, so I'm left with just y. Drop my plus. 6 times 1 is 6, divided by 2 is 3. I still have to keep my y. Equals, 6 times 10 is 60, divided by 3 is 20. I could have also looked at that one and said 6 and 3 have something in common. 3 goes into 3 one time, 3 goes into 6 2 times. 10 times 2 is 20. Doesn't matter to me which way you do it. Either way is fine. You just need to keep up with what you're doing there. So I multiplied both sides with LCD. Now I'm going to solve by isolating the variable. Combine like terms. I've got y plus 3y is 4y equals 20. I'm going to use the multiplication property of equality to get rid of this 4. It's 4 times y. The opposite of multiplication is division. So I'm going to get y equals 5. And you can plug 5 back in and check. All right. So get one that maybe throws us off a little bit just because it looks a little bit different. So example 2.4c, now I've got x plus 1 over 3 minus x equals 3. All right. So on one like this, it looks worse because now we have a binomial as the numerator, and maybe we don't really know what to do. The hint is, this is still a fraction. I don't like fractions. I want to clear them. I want to get rid of them if I can. Step one, find the LCD. I've got 1, 2 terms on that side, 1 on this side. There's an understood 1, understood 1. 3 has to be my LCD. So I'm going to multiply both sides by 3. And I'm going to get this 3 and this 3 will cancel, leaving me with x plus 1. That's when I multiply times this one. When I multiply times this one, I got to bring my minus. 3 times x is 3x, divided by 1 is still 3x. Equals 3 times 3 is 9 over 1 is 9. So I multiply both sides by my LCD. Now I'm going to solve by isolating the variable. X minus 3x, that's going to be negative 2x plus 1. I combine to my like terms, equals 9. Now I want to get rid of my constant. Subtract 1 from both sides. Negative 2x equals 8. Get rid of that negative 2. It was being multiplied. The opposite of multiplication is division. So I get x equals negative 4, and I'm done. All right, so these, we can make them as hard as we want, or we can quit letting fractions overwhelm us and realize that we're the ones in control there, and let's clear them out and get them out of there. All right, so that should get you through section 2.4. You've got plenty of practice and homework problems to work on. When we come back, we'll look at clearing decimals.